start recording. I'm gonna close this and we're gonna go for um, Google, and then we're gonna go for Secureum Solidity 101. Okay, so let's go. If you try to watch the video, you're gonna take much more time to do it. So it's really better when we do it like this. Okay, everybody's ready? I'll take that as a
Yeah, we're
yes.
ready.
Nice. Hey guys, sorry for my terrible reading English, but let's do it. So, Solidity is a high level language for implementing smart contracts on Ethereum and targeting the EVM. Solidity was proposed by Gavin Wood and was later developed by the Ethereum Solidity team led by Kristen, Alex, and others. It's influenced mainly by C++, a little from Python, and early on from JavaScript. The syntax is OOP, which means object oriented, and concepts are from C++. Solidity modifiers, multiple inheritance, C3 linearization. I don't know what that is. Let me find out. Anybody knows what this is? C3 linearization. Oh, it's how you resolve conflicts between inheritance. So we have several. Okay, better not to talk about that now. And the super keyword are influences from Python. Function level scoping and var keyword were JavaScript influences early on, but those have been reduced since 04. Okay, so we know that since 04, we have less JavaScript influence. It's really important to be tied on the version thing. You guys need always to be thinking on the version thing here. Solidity is statically typed, supports inheritance, libraries, and complex user-defined type. It's a full-feature, high-level language. The layout of a Solidity source file can contain an arbitrary number of pragma directives. Now, okay, because I can have a pragma that is from 4 to 9, so that would be like more than one. Okay, import directives and struct nums and contract definition. The best practice for layout between a contract is following the order. The following order: state variables, events, modifier, constructor, and functions. So variables, storage variables of the contract, go first, all the events, then you put the modifiers, then the constructors, and inside the functions, if I'm not mistaken, you gotta put you're gonna order by visibility and always finish with the internal functions. So the end of your contract will always be, full of internal functions. Okay. Um. So we have the SPDX. I wonder what SPDX means. No. Solidity search files are recommended to start with a comment indicating its license, where the compiler includes the supplied string in the bytecode metadata to make it machine readable. SPDX stands for Software Package Data Exchange. Okay, now we know it. This is gonna be one of the questions for sure. Pragmas. The pragma keyword is used to enable certain compiler feature or checks. A pragma directive is always local to a source file, so you have to add the pragma to all your files if you want to enable it in your whole project. If you want to import another file, the pragma from the file does not automatically apply to the import file. There are two types: version A, compiler version B, ABI coder version 2. Okay, so we don't even need to think about this right now. The thing is, the important piece of information here is that the pragma does not automatically applies to the importing file. Which means that if I have different compilers for different files, I'll have different functionality for the same function. And also, there's something important here that I forgot to mention, that you can import not only contract definitions, but you can import also in nums and in structure. And I guess a good way to see that, if you have this really complex, really big contract, abstraction, really huge code base, You want to have all your enums, enum types in a separate certain place, and maybe you want to have all your structs in another place, Anyone want to say anything? Hey, winner. Hey, Ethnical. How's it going? Hey, everybody here. Okay. So let's go for someone is with the mic open. Winner, can you close your mic, please? Let me close your mic. Awesome. Okay, now let's talk about the version pragma. This indicates the specific Solidity compile version used for that file and is used as follows. Pragma Solidity XYZ, where XYZ indicates the version of the compiler. Using the version pragma does not change the version of the compiler. It also does not enable or disable features of the compiler. It just instructs the compiler to check whether the version matches is the one required by the pragma. And if it does not, it issues a compiler error. So just I guess the important take out of this is that when you specify the pragma in your smart contract, you're not actually setting the compiler, you're just setting a check for that version. The compiler is actually specified during the execution of SOC. So yeah, I thought that just by setting the pragma, you would be actually setting the compiler, but it's just a check to see if that version matches. The latest compiler versions are in the 0.8z range. A different Y in Z indicates break changes. Okay, so this is a little bit about semantic versioning. Let me talk to you guys about this really fast. It's really easy to understand. So you guys gonna see softwares with things like 1.0.1, and so what this number means is first is major, okay. Second is yeah, I think this is major, this is breaking changes, and this is minor changes. So every time you see a software and you see that something like this happen, those could be breaking changes. And when you see something like this happen, it's just like some fix for optimization, some security bug fix, And when you see the first number changes, is like completely new software. And of course, this is a completely stupid explanation, but you guys can just check the Semver website, semantic versioning, so you guys can check what is the actual specification. Mine's gonna be in Portuguese here, but yours gonna be in your language, and you're gonna explain how this thing. So we know that Solidity is taking basis on semantic versioning. Okay. Now he's talking a little bit about the floating point operator, that we know that how it works. So he's gonna take functions up to that. Let's read it, right? Okay. So the float, a pragma symbol prefixed in y, x, y, z in the pragma indicates that the source file may be compiled only from versions starting with XYZ until XYZ plus 1, Y plus 1. So if we do pragma solidity float 083 indicates that the source may be compiled with version starting from 0.83, any 0.8z, so any variation in the middle number, but no variation in the major number. So when we have solidity 0.9, these won't catch those compilers, okay? This is known as a floating pragma. Complex, this is also not recommended on deployment, production smart contracts for obvious reasons. You don't want to have any sort of change in the compiler running the code, so you're always going to have a fixed version. I don't know if this is a rule, but I guess it's a common guideline. Complex pragmas are also possible, so you can use equal, bigger or equal. So I can say, okay, you can run these from 0.08 to 0.03. And one use case for this would be after 0.03, we don't have this opcode anymore, so the code can be a little bit more expensive to run. So these kind of hacks, um, Then we have the ABI coder pragma. This indicates the choice between the two implementations of the ABI encoder and decoder, the V1 and V2. The new ABI coder V2 is able to encode and decode arbitrary nested arrays and struct. It might produce less optimal code and it has not received as much testing as the older encoder. This is activated by default. So by default, we're using the ABI coder v2. Okay. The set of this I think this was introduced after 0.8. I'm not sure though. The set of types supported by the new encoder is a strict superset of the one supported by the old one. Set of types supported by the new encoder is a strict superset of the one supported by the old one. Contracts that use it can interact with the ones that do not without limitations. The reserve is possible only as long no ABI encoder v2 does not try to make calls that would require decoding types only supported by the new encoder. The compiler can detect these and will issue an error simply will issue an error. Simply enable ABI coder v2 for your contract is enough to make the error goes away. So let me just go back a little bit in this. And the set of types supported by the new encoder is a strict superset of the supported by the old one. Contracts that use it can interact with ones that do not without limitations. The reverse is possible only as long non-ABI coder v2 contract tries to make calls that will require decoding types only supported by the new encoder. So I guess that means you're doing some sort of, hashing or signature, calculating signatures, using structs or nested arrays like he's saying here, and that would break. So whenever you're using ABI encoding and decoding, be aware everything is compatible, because otherwise the compiler can detect these and will issue an error. Simply enabling ABI v2 for your contract will make the error go away. So if you have a node contract, you can go there, enable the ABI v2, and maybe deploy a new address and change the implementation or point to the implementation. Okay. The pragma applies to all code defined in the file where it's activated, regardless of where the code ends up eventually. This means that a contract whose source file is selected to compile with ABI coder v1 can still contain code that the new ABI coder that uses the new ABI coder by inherited from another contract. This is really shady thing, So go back to this again. This pragma applies to all code defined in the file when it is activated, regardless of where that code ends up eventually. Okay? This means that a contract whose source file is selected to compile with ABI coder v1 can still contain code that uses the new ABI encoder by inheriting it from another contract. So if we are inheriting functions and they use the new ABI encoder, you're going to be getting, even though you specified ABI coder v1, you're still going to be getting ABI coder v2. This is the kind of thing that make you find some good findings. This is allowed if the new types are only used internally and not externally. So there's also this detail. Woo! A lot of things to wrap our minds around. Experimental pragma, this can be used to enable features of the compiler or language that are not yet enabled by default. The SMT checker, the use of pragma experimental SMT checker, performs additional safety checks by querying the SMT solver. Are you guys there? Hearing anybody yet? Um,
Yeah, exactly.
Awesome. So the SMT checker model automatically tries to prove that the code satisfies the specification given by requiring a certain statement. That is, it considers the requirement statements as assumptions and tries to prove that the conditions inside the assert statements are always true. If an uncertain failure is found, a counterexample may be given to the user showing how the assertion can be violated. If no warning is given, by the SMT checker, it means the property is safe. This is we're talking about different kinds of checks. I think there's eight or nine different kinds of checks. One very famous one is for the underflows. So here we have a list. We have arithmetic underflows, division by zero, trivial conditions, and unreachable code, popping an empty array, out of bounds index access, incest, insufficient funds or transfers. By the way, Viper fixes all these things by default. Um, um, yeah. So whenever you're using, so you don't really need to use the SMT checker after version 0.8. At least that's what I understand, because it's already there, it's already enabled by default. But what's gonna happen is when you're doing like some calculation in your code, like let's say you're summing two numbers, and you have a code using the SMT checker and a code that's not using the SMT checker, when you go to compare both bytecodes of the same function, you're gonna see that the function using the SMT checker has a lot of code, like a lot of more code doing the, protection against underflows, protection against overflows. You don't see all these things, but they are out there, okay? So here he's explaining about, all checks regarding arithmetic underflow and overflow, division by zero, trivial conditions, reachable code, popping an empty array, out of bounds index access, and insufficient funds for a transfer. Okay, talk a little bit about imports. Solidity supports import statements to help modularize your code that are similar to those available in JavaScript. You can do some import file name. You can do comments with two, I think, slashes, right? And you can also do multi-line comments. Very nice. Um, the comments are recommended as inline documentation of what your contracts are doing. So yeah, as you read the contract, you're gonna see people over commenting contracts. Overall, in development, people don't recommend you using too much comments. So they say code should speak by itself, but with Solidity, I think it's cool because it's such a critical usage that has no way to fix that. It's really important that you can have like the proper English line and yeah, let me see who's here. A lot of cool people here. Um, let's talk a little bit about net spec. I won't be reading all these things. I will just explain that to you really fast. So let me open a Solidity file. So if you guys go on Google and search for net spec, pretty much a standard way of doing comments, of leaving special notation. That's a word here, okay, guys? Notation in the comments. So we're talking not spec. We're talking about having the I know who's the title. So I have the title, the author, the notice. Just like I can do here in this code that I have here on my screen. I can come in this function here and say something like author, and then I can say yeah, some topic. This is net spec pretty much. So the pretty much ways of specifying pieces of your code, like we see all the time. So here they are saying the title, the author, notice, def, and you can even have, for us there are auditors, there's a Solidity visual developer that they add a few tags, like you can have some like audit notes, or audit, or to audit. So they have all these cool additional net spec tags. Okay. So I hope everybody understood that. It's just pretty much the way we do. So just to go over each one of them, title, author, notice. Explain to an end user what this does. So instead of being description, someone decide to call it notice for some reason. Def. Explain to a developer any extra details. Param documents the parameters so you can have an explanation for each one of the parameters. And return, what is the return type? Inherit doc. This is a good one. This is a special one. So let's say I'm overwriting a function and inheriting something from another contract. Whenever I do this inherit doc, I'll be inheriting all the documentation on that function. So Usually we do these things so we can run a software in the end and create this sort of documentation of the platform of the software, and you can just read, what all the functions are doing. And it's also useful for editors to give you, a little bit of context of syntax and everything. Okay. Now let's go over contracts. This is a big one. They're similar to classes in our object-oriented language in that they contain persistent data in state variables and functions that can only modify these variables. Contracts can inherit from another contracts. So we can have a chain of contracts, okay? And whenever a contract is calling another contract, inside the compiler, or say the program counter, you have something called the call stack. And the call stack is pretty much the list of contracts calling each other. So if contract B calls contract C, or A calls B and B calls C, you're gonna have your call stack being A, B, and C. Contracts can contain declarations of state variables, functions, function modifiers, events, errors, issue types, and enum types. Anything new that we're forgetting here? Let me think. I don't think so. I think so. State variables. Those are variables that can be accessed by all functions of the contract and whose values are permanently stored in the contract storage. It can easily be specifiers. So here we're talking about public, internal, private. So let's go over each one of the visibilities. Public. Those are part of the contract interface and can be accessed either internally or via messages. So whenever we do something internally, we are, what is the best way of doing that? We are doing a call. And whenever we do things with transactions, we are sending messages. Okay, so there's a little bit of a difference in that. Internal state variables can only be accessed internally from within the current contracts or contracts deriving from you. So let's go over this one. So if I have a contract A, contract B, let's see if we can, it'd be really nice for us to be able to just, put up these things really fast. Let me just try to. Also, if you guys understood, I can also not do this, but I'll just copy these so you guys understand. I'll have contract A, contract B, and I'll say that B is A. Okay, so we inheriting from it, and then according to the documentation that we're just reading, the internal variables can only be accessed from a current contract or contracts deriving from it. So that means that if we have, I'll even put this maybe on remix, maybe that's easier for us. So if we go on remix here, it's gonna be a little bit long session. I hope everybody's comfy. And if anyone has anything to say, question, please feel free, guys. Okay. Running the server. Let me go over contracts and open contract. Any contract can be on here. Is this? So we are saying that whenever we have, okay, so let's go back here. Whenever we have a internal state variable, it can only be accessed here. So I guess I could do maybe maybe address internal. Can I do that? Internal owner. Technical you there. This works, right? So in this contract here, like I could do it. I don't know if it's construct or constructor. I think it's constructor. Um, Here I could do like something like, if I have this console log, let me just do this import. I think is hard hat console.saw. And if we do like function test, okay, and we can see the test returns. You can see test is external and returns the address. Um, Someone help me here. Overcheck and ask me to fix this contract. Oh, bro, really? You're gonna take like the whole fucking year to do this? Huh, the code is right, isn't it? No, something was wrong. I wonder what it is. Oh, there was no code. Does anybody see the difference? No, this was the one that's broken. Not broken anymore. So we could do something, I guess we could do something like console.log owner. And here we have access to owner, even though it's internal because we inheriting from the contract, you know? So yeah, this is where I was trying to talk, so maybe a little bit visual. Private. Private can only be accessed from the contract they are defined, not even in the derived contracts. So if this was private, I wouldn't be able to access owner. Actually, I think I can do this a dot owner here because this variable, you know, is private. So let's see if the error is regarding that. Yeah, you see, it's not found, no visibility. Let's change to internal and see if that works. We change it to internal, wait a little bit. Looks like we don't have a problem anymore. Okay. So private, only in the contract that you are, and private is not really private. Private is only private in the context of the smart contracts, you know. So you can always look at the storage of the smart contracts through the RPC nodes using commands and check out the value in there. Okay. Let's go for state variables, constant and immutable. Okay. Uh, um, so they can be declared as constant or immutable. In both cases, the variables cannot be modified after the contract has been constructed. This means that if this variable is immutable, I can only set it during the deployment. So I can only do like, you know, constructor immutable equals address, no, 0. Okay. It's not immutable, sorry, zoner. Mm. So this is really the only time I can come here and set this value. If I don't do this at this point, I won't be able to do it anymore. So yeah, that was that. And it has to be fixed at compile time. While for immutable, it can still be assigned at construction time. So let me just go back over that. For constant variables, the value has to be fixed at compile time, while for immutable, it can still be assigned at constructor time or point of declaration, meaning that it has to be declared once, you know. So just one thing here, one detail. When he's saying that it has to be fixed at compile time, it means that every time I have a constant, so if I have a UIN 256, you know, let's say price is not really good to be a constant. So let's do something else. Let's do one ether, okay. And I can say constant, and I can say, hey, 1 ether is equal 1 plus, I think it's 1 times 18 or something. So this is like how much units composed 1 ether, you know, and I could have like the biggest contract here, going over and doing all the code. I could have like these, you know, I could have something like, you know, whatever price, the Ewing 256 price is equal 1 ether times 2. Let's say, you know, I could have something like that. When we're looking at the text value needs to be fixed at compile time, it means that in the compile, what's gonna happen is the variable will be replaced by this. So we're gonna replace all instances of the constant by the value at compile time. Okay. For constant, the value and for immutable, I don't know if it's the same or if we go into storage. Okay. For constant variables, the value has to be a constant at compile time, and it has to be assigned where the variable is declared. So which means that, you know, whenever I'm doing a constant, I cannot do this. I cannot do like 1 ether this and say that 1 ether. I think I cannot do this is equal to. So yeah, okay, I can't do it. I know I can't. Okay, nice. So if I'm doing a constant, I need to just declare whatever, like I need to declare it right, you know, properly at the right place. I need to put the value right in there. Go back. And any expression that access storage, blockchain data, balance, execution data, or makes calls is disallowed. So if you try to be a smart guy and say, hey, my constant is block dot timestamp, for some reason, it should break. It shouldn't work, and we have an error here saying this type is not callable. Okay. Are you guys following? Is this being good enough? Can you guys give me some feedback? Guys? Okay. I'm gonna take that as a yes. Can you hear me?
Yes, yes.
Okay.
It interrupted
Um,
something.
nah, no problem. Immutable variables can be assigned an arbitrary value in the constructor of the contract at the point of their declaration. They cannot be read at constructor time, can only be assigned. This is really like important and small, you know. So we're basically saying that, okay, so I'm gonna have this immutable variable, right? So let's say it's the owner. So I'm gonna do like I have the owner in there. Let's say I did this address 0. I don't think that this is possible, but let's say that I went here and did like the 0. You know, I typed it myself. Don't need to get it right here, the amount of zeros, but you guys understood. And I couldn't check that here. That wouldn't be available for me. And the whole reason is whatever is happening inside the constructor, this code doesn't really exist yet. The constructor will still create all the code. So that's why you cannot read things from the constructor. You can only set them. So what I will be able to do, let me do some control Z's here, is what we have here now. So I'm able to create the variable, declare it, and then set a value on the constructor because of the immutable. Okay.
Miss,
Go on.
we don't see anything.
Okay. I think my screen sharing.
No, we don't see nothing.
Okay. But now you guys. But the whole time or just now? Just now, right? Awesome. The compiler does not reserve a storage slot for these variables and every occurrence. Okay, so this goes back to what we talked before, that whenever you have a value, so if I have like u in 256, immutable 1 ether equals 118, like that, sorry, 1 exponential to 18 units. Whatever I do with this variable, I'll always be using that. There's no storage. That is the same for immutable and is the same for constant. No storage is involved. Everything is replaced at compiler time, meaning during the compilation, the bytecode will use that. That's much more efficient. I don't have to do swaps, all the bytecode processing, the stack processing to have these values around, okay? Well, this is going to take a lot of time, but the speed we're doing this. Compared to regular state variables, the gas cost of a constant and immutable is much lower. This is really important. Every time you guys can use immutable, every time you guys can use constant, use it because the gas is much lower. Imagine having to do all the storage operations to get a value, or just having the value in there. Like because of this thing in here. Can you guys see my screen good, or is very small? Should I make the letter bigger?
Yeah, we see it.
Awesome. So because of
Looks good.
yeah, okay. So let's go back to that, okay? Every time you have the chance of using a immutable variable, and this is really easy to miss because here on the one ether, I could just not say this, and have the variable to be, I could even have it private or something, but when I do it immutable, there's no storage. There's no storage operations to get it. We just replace the values. So be very aware of that. Okay. Um. So let's talk a little bit about the gas details of this. For a constant variable, let me just see how much time of recording I have at this point. I just want to open gas. Okay, 37 minutes. Okay. Okay, so for a constant variable, the expression assigned to it is copied to all places where it's accessed and is also reevaluated each time. This allows for local optimization. Mutables are evaluated once at construction time and their values copied to all places. For these values, 32 bytes are reserved, even if they would fit in fewer bytes. Due to these, constant values can sometimes be cheaper than immutable values. So you need to consider really well your use case to see, if that's really what you're going for. Um, the only supported types are strings, only for constants, and value types. Functions are the executable units of code. Functions are really defined inside a contract, but they can be defined outside contract. They have different levels of visibility towards other contracts. So he's talking about how I have functions that are external, there's internal, and what kind of functions I can see in the other contracts, other kind of functions I can't. Um, let's go for function parameters, okay? Parameters are declared the same way as variable, and the name used of the parameters can be omitted. The function parameters can be used as a local. So this is a really cool thing with Solidity. Some people will consider it cool, some people will not consider it cool. I'll just do this just because I know maybe, I don't know, probably you guys all know this stuff, but I'll just, just to make sure. When we're talking about functions, so this is a function, it's a piece of code that we're gonna run to do something. In this case, we're just logging on the owner, but we could be doing something different here. And I don't even need the A anymore because I'm not heading to the contract. And parameters are things that we put inside the function. So if this function was sum, I could have 2 unit, 256, and anyone, and you will never use numbers for your variable names, okay? And I can just do here, something like return 1 plus n2 or something. No, and change this to u. So these are the parameters, and this is the function. Now there's something really cool with Solidity. I can have a function with the same name, but more parameters. So what means that I can have like different implementations for the function. So I can have here a version of sum that also takes a third number. So what? So here we have the same function with the same name. The contract is not broken. What's changing is the total of parameters. And this only works because the way we compose the ABI. Sorry, I did some fuck up here. Yeah, I think it was just a bug. Because when we're doing the signature, we also take into consideration the parameters. Thus, this signature will be different from this signature. Okay, so this is what we're talking about when we talked about that function parameters can be declared and the name of unused parameters can be omitted. Function parameters can be used as any other local variable that can be assigned to. Okay. Now let's talk a little bit about return. Function return variables. Function return variables are declared with the same syntax after the returns keyword. The names of the return variables can be omitted. So return variables can be used as any other local variables. You can explicitly assign. So you can either explicitly assign the return variable and leave the function as above, or you can provide the return value. If you use an early return to leave a function that has return variables, you must provide the return values together with the return statement. When a function has multiple return types, can be used to return different values. Let's talk a little bit about returns here. Okay, first thing I want to show you guys about returns is when they say number, the name can be omitted, is because I could have here the result as a name of the return. And if I'm not mistaken, if I do this, I don't even need the word hit return here. I can just do that, and he will automatically return that for me. I think it's a little bit less readable, but it goes from each developer. Each one of you has a favorite preference over that. Um, um, thing. Okay, so returning multiple values, right? And also in Solidity, you can also return, different things. So I think I can return these like, okay, so Boolean, and I can say return the result, and let's return a Boolean. If the number is, if number one is bigger than number two or something, so I can say Boolean, and any one is bigger. I think I can do this. I just don't know if I need to put those into an array. You see that? Yeah, and use it parameter. And I think, I wonder how this return works. If I just say anyone is bigger, I wonder how this works. If I just can say, like, I can say something like return these, returns these, plus true or something, and then I'm returning. So what I'm returning here is number one and plus number two, so result, and number one is bigger. But I think the syntax is probably wrong. It's not returns, it's just return. And I need a semicolon here too. Let's see if that actually works. No. I wonder if I should do this. This is even possible. Yeah, looks like this works. So with this, I'm returning. So now this function returns the sum of both numbers and a true. Let's see if that works. I'm really curious about that thing now. So we're gonna just go over. So this is Remix, your best friend from now on. Probably you guys know it already. I'm gonna even make the fonts a little bit bigger here so we can get really used to it. There's not a lot of secrets to Remix. Usually we're gonna be using that, and this one. These ones to choose the compiler. Let's go with 8.018. You're gonna see that, I'm only being able to use that compiler because I'm using the float pragma that allows us to start from 0.8 and go to the next change, to the next not breaking change. I also have this auto compile tag, so every time I change the code, it compiles automatically. I don't need to keep on, and to make to test it really fast, instead of having to deploy things and make it really complicated, you can just deploy it on the virtual VM of Ethereum. So you have merge. This is a JavaScript virtual machine. So you can just test things. I can just deploy the contract. It's deployed. And I can say, and now I have this, I have choose, you see that I have choose some functions. One for that will return, takes two numbers, and one that takes three. Let's make a test here, and let's try to sum. I'm gonna go for Etherscan unit converter. Let me just try something first. I'm gonna just try to do 1 and 2 and see what we get back. Yeah, the function work. Let me see something, but we're not getting the result in here. I'm not gonna be focusing on that right now. Okay, let's go. You can either explicitly assign return variables in the function as above, or you can provide a return value directly within the return statement. You can use an early return to leave a function that has return variables. You must provide the return values together with the return function. When a function has multiple return types, the statement return can be used to return multiple values. This number of components must be the same number of components of the variable and their types to match. Just don't think about these functions to sum here. I just wanted to talk really fast with you guys. This being specified the way it's here doesn't make a lot of sense because we're not really using no storage from the blockchain. So I guess it's safe for us to set these as views, maybe pure, but I think it's safe for us to set these functions as views, and we can do external view on both. I don't know if view or pour is better here, but we're gonna go that over the documentation. I just want to know if now having the view instrumentation, I can actually see the result. That's what I want to see. Yeah, so I have the result here for tree, and so I'm returning two types. And now one of the tests I want to do is if I remove the return keyword and just deploy it and just do the same thing, you guys can see that I don't have the basically the return is not returning automatically. So yeah, so always need to add the return keyword. Okay, but it didn't broke the code too, so be aware of that. Let's go back. Function modifiers. Okay, we know about the modifiers. They are really important in Solidity. They act like guards for certain functions. So thinking on this function here, we could have a modifier that say only, like I can say only numbers below, below is only 5 modifier. I think it's modifier number below 5. Only number below 5, and here I need to pass the numbers. Okay, so what I can do here, let me just see the problem. Modifier body. Okay, it's not important. So what I can do here is I can say, hey, require that n1 is bigger than 5 or smaller smaller than 5. Okay. Or smaller or equal. No, smaller. We said below. And 2 also needs to be smaller than 5. I don't know if I can do things such as, like those complex logic stuff. So when I do this, so let me explain to you guys. A modifier is a way of assuring that the code will only happens if certain things are matched. Is commonly used for the owner, so you're gonna have the only owner all the time. Because we're talking about summing numbers here, I'm just giving you guys a example of how we could use this if we're only accepting to some numbers below 5. And I can even put a message here or create a nice error type and say, hey, only below 5. And I can just add this to my functions. Right after the view, I can say, hey, only numbers below 5. And I also think I need to specify the parameters here. I'm not sure though. Okay. We're going to find out that right now. So if we try to test this, if we try to deploy this contract, and I do sum of 7 and 5, I get a revert. And now I have the error here. Look, only below 5. So first thing, line 15, this underscore, this means do this and execute whatever is the code that's coming. So all the code that's here, pretty much this line. Okay. I could also have something else here, I could also have some other logic happening here. So I could say, hey, otherwise, do that. This is a little bit of a more complex case. I don't see it a lot. But just so you guys know, I can have something running at the beginning of the function, run the code of the function, and at the end of the function too. Okay. Yeah. I want to make a few questions. Are you guys understanding the modifier? Any questions about it? I do. The fuck? I don't understand. Hey guys, did I leave the call? What happened? Hello, hello. Can you hear me? Hello, hello. Can you hear me, guys? Did I leave the call? Did you guys saw what I was doing on my Discord? Is simply like restarting. Okay, I'm gonna go back. So you guys are seeing everything, right? Let me do a little bit of a. I wanted to do a little bit of a pause. I'm gonna stop. We just saw the modifiers. They allow you to protect your function and do some assertments and requirements in a more decoupled way, meaning that you can use those modifiers in different functions. Okay. Let's talk a little bit about. I'm just gonna see something. Yes. Okay. 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 A little bit to go. Let's go. Let's talk a little bit about visibility specifiers. So here we're talking of. If you guys are seeing my screen. Here we're talking about the visibility of each function. So it could be public, external, internal, or private. Okay. So let's go over each one of them in detail because as those basic theses is always good to be remembered and reminded of the fundamentals. Okay, public functions are part of the contract interface and can be accessed either, internally or via messages. We talked about calls and transactions when distinguishing following internally and via a messenger. External functions are part of a contract interface, which means they can be called from other contracts and via transaction. An external function f cannot be called internally and does not work, but these.f works, because whenever you use these, you preserve the context. Okay, no need to worry or think about that right now. Internal. Internal functions can only be called within the current contract or contracts deriving from it, okay? And private functions can only be accessed in the contract they are defined. It means that if I have a function that's private, not even if I inherit it, I'll be able to run over it, okay? So let's go over functions, mutability specifiers. Functions can be specified as pure or view. We just talked about that while doing the something to see the return. A view function can read the contract state, okay, but cannot modify it. This is enforced at runtime via static call, the static call opcode. Following are considered state modifier: writing to state variables, emitting events, creating other contracts, using self-destruct, sending a ether via call, calling any function not marked as yours root, using low-level calls, using inline assembly that contains certain opcodes. So here we're pretty much saying that a view cannot do all these things. Okay, now let's see what is the difference for the pure function. So a pure function can neither read contract state or modify it. So this is purely for doing helpers, maybe some calculations. The following are considered reading from the state: reading variables, assessing balance, assessing any members of block, tx, or message, so message call, block.timestamp, calling tx.origin, calling any function not marked as pure, using inline assembly that contains certain opcodes. One good question here would be for interviews and things is like, can you use inline assembly for pure and view functions? And yes, you can, but not for all bytecodes. It's not possible to prevent functions reading the state at the level of the EVM. So now we're talking about, I can always look at the storage. I can always look at the storage. It's only possible to prevent them from writing to the state via static call. Therefore, only view can be enforced at EVM level, but not pure. Didn't quite understood this one. It is not possible to prevent functions from reading state at the level of the EVM. It is only possible to prevent them from writing to state via static call. So you know that when you do a static call, you cannot be writing anything. Therefore, only view can be enforced at the EVM level, but not pure. So I guess at the EVM level, a pure function will not be treated differently from another function. Okay, just at the solidity level, it allows you to protect it a bit better. Function overloading. A contract can have let me Oh, guys, let's go. A contract can have multiple functions of the same name, but with different parameter types. This process is called overloading. So we talked about how we had different kinds of sum functions. Overloaded functions are selected by matching the function declarations in the current scope, the arguments supplied in the function call. Return parameters are not taken into account for overload resolution. Return parameters are not taken into account for overload resolution. An interesting one, I guess. What we mean here is that if I have two functions with different parameters, the return part will not be taken into account when considering that a new maybe is not part of the signature. Free functions are functions that are defined outside the contract, and they always have implicit internal visibility. Their code is included in all contract that call them similar to a library function. This pretty much means that I can have functions outside the contract. So I could have a function like this one here. I could have one here outside the contract. And I think I will only have to change this. I think I don't need to put up the visibility. I can just say that it's a view. And I can then use some now on all contracts that are here. Okay, this is called a free function. Events are abstraction in the top of the EVMs, to log everything. And these logs are associated with the address of the contract and are incorporated into the blockchain instead as long as the blocks is accessible. The log is event data is not accessible from within contracts. Applications can subscribe and listen through the RPC interface. So basically, you cannot read logs from the events from the smart contracts, but you can read them from off-chain, off-chain whatever. Index event parameters, adding the attribute index up to 3 parameters, adds them to a special data structure known as topic. Instead of data part of the log, you use arrays, including strings and bytes, as indexed argument. Its kcheck 256 hash is stored as a topic instead. This is because a topic can only hold a single word. All parameters without the index are ABI encoded into the data part of the log. Topics will allow you to search for events when filtering a sequence of blocks for certain events. You can also filter events by the address of the contract that emitted the event. So here we're talking about events, okay? So I could have an event here. And I can say event number sums, I guess. And then I don't really remember the syntax, but I think it's u in 256 number 1 and 2 in 256 number 2, and I can have, yeah, okay, so this is an event, right? and but this event is not really searchable for me the way it is right here. To make it more searchable, I need to make it indexed, and I can do that up to 3 parameters. Before 8.0, I think we can do it with 4. After 8.0, 0.8, we can do it with 3. And when I say searchable, is now I can go on my RPC client through, let's say, the terminal, and I can search all the sums that happen using this anyone, so anyone tree. So everybody that sum tree to something, I know. So this is what we're talking. Emits. Events are emitted using emit followed by the name of the event. If I wanted to emit event, I will pretty much go over here, and I could have one more line or not. I'm just gonna do an emit, number sum and 1 and 2, and boom, putting out the event. And I think it's emits, or I don't know if emits. Let's see what problem. Yeah, I cannot. It's nice because it goes back to the other point we just talked about. So internal, I cannot have a view. I cannot have a view that will emit events. Okay, but if this was not a view, there will be no problem in emitting the event. Structs. They are custom types. They group several variables, and they are assessed using the dot, so like a JavaScript object. So let's just copy the structure here, so I can show you guys practical example. So I can have a structure here called, we could have a struct and say, calculator. It's not the best. Okay, I'll maybe jump this one for now. Enums can be used to create a constant values to improve readability. The minimum of one member, they need a minimum of one member. It can have a maximum of 250. They can be explicitly converted from to string to integers, and the options are represented by unsigned integer values. Starting from 0, the default value is the member. Enums are just a way of making your code look nicer. Okay, usually you don't want to be comparing things with numbers, so you don't want to be saying if whatever if x equal 1 do this. But if you have an enum that says that 1 equals, let's say 1 enum whatever, like I can say enum, and I can say test. This is probably not the waiting. Okay, test. I don't know how to create enums here, but something like that. And I can now say, yeah, okay, so if x equals test.past, you see, that's much easier to read than having a 1 here. So that's when enums come. So they can be used to create custom types with a final constant values to improve readability. This is the important part of the enum thing. We are improving readability. It's better than having 1 in there. Solidity is a static typed language, which means that the type of each variable needs to be specified in the code at the compiler type. This is unlike the dynamically typed languages, where types are required only within runtime values, and statically typed languages to perform compiler type checking according to the language rules. Other examples are C, C++, Java, Rust, Go, and Scala. So pretty much talking about how we need to declare all the types and everything. Okay. So Solidity has two categories of types: a value type and a reference type. This is an interesting one. Okay. Value types are called so because variables of these types will pass by value. They are always copied when they are used as functions arguments in assignments. Let me read that again, okay? Solidity has two categories of types: value types and reference types. Value types are called so because the variables of these types will always be passed by value. They are always copied when they are used in a function argument or in assignments, which means that every time that I'm using that variable and another function, I'm actually at the compiler level copying that value, okay? But I can also have a reference type, and I think here we're talking about the call data variation for the variables, where they can be a reference types can be modified through different names, references to the same underlying variable. Actually, I don't know if this is a call data thing. Okay. Value types. Value types are passed by value. They are always copied when they are used in function arguments or in assignment. Booleans, integers, fixed point numbers, address, contract, fixed size byte arrays, literals, address, rational integer, Unicode, hexamer, enums, and functions. These are all value types. And for reference types, what we have is we have arrays, including dynamically sized bytes arrays and strings. So this is really important to know, okay? If we're talking about dynamically sized arrays and strings, we're talking about reference types, and for structs and mappings too, okay? Default value. So this is pretty much talking about, I think, let's read this better. A variable which is declared will have an initial default value, which is a byte representation is all zeros. The default values of variables are typical zero state of whatever the type is. For example, the default value for a bool is false. The default value for a uint is 0. For a statically sized array of bytes and bytes 1 to bytes 32, each enum individual element will be initialized corresponding to its type. For dynamically sized array, bytes and strings, the default value is an empty array or string. For the enum type, the default value is the first member. Scoping. Scoping Solidity follows the widespread scoping rules of C99. So in the C days, we had all these versions of C, C89, C99. Variables are visible to the point right after the declaration. I'm going to be reading about scopes. Boolean. A Boolean keyword and its possible values are constants, true and false. Operators like exclamation mark, which is a logical negation, and logical conjunction, logical disjunction, or equals. Okay, these are all booleans. Operators that say or and apply the common short-circuiting rules. This means that the expression f or g, if x evaluates to true, g will not be evaluated. Okay. Integers. Signed and unsigned integers of various size. Sorry. Keywords uint 8 to uint 256 in steps of 8. Unassigned of 8 up to 256 and int 8 to int 256. Uint and int are aliases for both using 256 in the end, okay? And here are all the comparisons you can do: bigger than equals, left shift, you know, the bitwise operations, and beautiful. We just see something. Okay. Integers in Solidity. They are restricted to a certain range. For example, uint32, this is from 0 up to 2 exponentiated to 32 minus 1. There are two modes in which arithmetic is performed on these types: by wrapping or unchecked, meaning that the wrapping for checked or unchecked. By default, arithmetic is always checked. When we're talking about checked, we're talking about the SMTP checker that we talk. It's not really SMTP, I think. But the checker that we talked in the beginning, and I cannot, and I like I told you guys that if you do use this checker, you're gonna be adding a lot of bytecode to the operations, and you can use unchecked operations that will deny all the safety features in there. Okay. The call is reserved to a falling assertion. You can switch to unchecked mode using the uncheck. This was introduced in compiler 0.8 because in 0.8 everything is checked by default. So if you want to do unchecked, you're going to be doing that. And usually the reason why people use unchecked operations is to save gas in some sort, you know, or because they are really sure that operation specifically will never be overflowing because everything is very controlled. Fixed point numbers. Fixed point numbers using fixed are not fully supported by Solidity yet. They can be declared but cannot be assigned or from. Assigned to or from. There are fixed point libraries that are widely used like tsmat, PRB math, and ABDK math. So these are some of the libraries you can use to do more advanced mathematics and maybe more precise mathematics. So address types, okay? So an address comes in two types. One that holds a 20-byte value, the size of an Ethereum value. This is also another one of those interview questions. And an address payable, the same address, but they have the additional bytecode to send and receive assets. Okay. You can also use these operators for addresses. And when talking about conversions from address payable to address are allowed, whereas conversions from address to address payable must be explicit via the payable keyword. That means that whatever works for address payable works for address naturally. But if you need things from address payable and you haven't declared that as payable, you need to cast it to convert it that address to a payable address. Okay. Explicit conversions to and from address are allowed for uint 156, integer literal, bytes 20, and contract types. Okay. Only expression of type address and contract type can be converted to type address payable via explicit conversion of payable. The contract type or contract type, this conversion is only allowed if the contract can receive either the contract either has received or payable a payable function. So what we're saying here is that um so let's read it again. It's better to read it again. Only expressions of type address and contract type can be converted to type address payable via the explicit conversion payable. For contract type, this conversion is only allowed if the contract can receive either or the contract has a receiver payable function. So if you have a contract does not have a receive or a payable function, you won't be able to convert to cast that into a payable contract, into a payable address. Okay. So what are the members of the address type? We have the balance that we're always using, the code at the address, the code hash, which is kind of the ID to load the code in the database, transfer function, send function, um, returns, delegate call, static call. Let's go over each one of those, what they do. From transfer, so sends giving amount of weight to an address, reverts on failure, and forwards the 250 guys spent. Okay. Then we have send. Okay. Send giving you the amount of weight to the address, return false on failure, forwards it to the gas and is not adjustable. We have call, which issues a low-level call with the given payload, return success and condition, and return data for its all available gas. Delegate call also does a low level with the payload, but now it's going to be keeping all the context, so will be the same as the sender, will be the same everything that initiated the transaction. And static call, we know that for calling views, basically things that will not change. Okay. So let's talk a little bit about the transfer function. The transfer function fails if the balance of the current contract is not large enough, and if the either the contract is rejected by the receiving account. The transfer function reverts on failure. The code receive the coding receive function the coding receive function or if not present in the fallback function is executed with a transfer call. Sorry. Transfer function fails if the balance of the contract is not large enough, okay? Or if the contract is rejected by the receiving account, the transfer reverts on failure. The coding receive function, or if not present in the fallback function, is executed with a transfer call. That execution runs out of gas or fail anyway, the either transferred will be reverted, and the current contract will stop the execution. The send function is the low-level counterpart of transfer. If the execution fails, then send only return false and does not revert, unlike transfer. So the return value of send must be checked by the caller. And this is also another point, really big point in interviews for security. They're going to be asking you transfer versus send, transfer versus send, and you better have these things, to answer them. Let's talk a little bit about call, delegate call, and static call. Um, in order to interface with contracts that do not adhere to the ABI or get more direct control over the encode, the function call, delegate call, and static call are provided. They're like they all take a single bytes memory parameter and return the success condition and the return data. the functions ABI encode and ABI encode packet and ABI encoder selector, ABI encoder signature can be used to encode structured data. Gas and value modifiers can be used with these functions. Delegate call doesn't support value. Delegate call doesn't support value. This is really important, guys. Okay? To specify the amount of gas and ether value passed to the Kali, with delegate call, the only code of the code of the given address is used. All other aspects, storage, balance, and message sender, are taken from the current contract. Purpose of delegate call is to use a library logic, which is stored in the Kali contract, but operate on the state of the caller contract. Okay? With static call, the execution will revert if the called function modifies the state in any way. Okay? Contract type. Every contract defines its own type. Contracts can be explicit, converted to and from an address type. Contract types do not support any operators. The members of contract types are the external functions of the contract, including any state variable marked as public. I'm gonna stop for here today, guys.